Alright, this video has to do with Newton's first two laws, the law of inertia and the law of acceleration, which comes along with the formula F equals m times a, force equals mass times acceleration. And the equation seems pretty intuitive, seems pretty simple, because if you think about how it works, the greater force you place on an object, the faster you're going to make it go, or the greater the mass it has, the more force is going to be required. But it's a little bit more complicated to that than that, and we can compare that with the law of inertia as well. So if we look at the simulation here, I'm going to take the mat, I'm going to apply a force to it, and then we'll see the object move, and we'll see how it moves by keeping an eye on the speedometer here. So I'm going to apply a force, and then I'm going to let it go, and if you can see that little glitch in the program, or you can see that it's maintaining a constant speed of 9.7. Alright, so that is a velocity. That's not an acceleration, right? So this is an example of inertia, not an example of Newton's second law, acceleration. Alright, because there's no acceleration involved here. The object is moving at a constant speed, and it's not speeding up or slowing down at all. Right? Now, what would be applicable is if I continue to apply the force, and this makes sense, right? If we just pushed it, then inertia would take over and it would just continue to go and go and go. But if I continue to apply a force, doesn't it make sense that it continues to speed up? Right? Oops, let's put the speedometer on. Alright, sorry about that, let's start over. Let's put the speedometer on. Okay, let's see the value of the speed. Alright, so if I continue to apply a force, then it makes sense that the speed will continue to increase. And you can see that looking at the speedometer that it's getting faster and faster and faster. So this is an example of Newton's second law, force equals mass times acceleration, because it is accelerating. If I let it go, now it no longer accelerates. You can see that the speed maintains a constant velocity, and that would be an example of Newton's first law, the law of inertia. An object in motion will remain in motion. Okay, so I hope that kind of clears things up, the difference between the two. And remember that inertia is me just pushing it and letting it go, and it's going to go and go forever until another force acts upon it, right, in a frictionless environment. And acceleration is a continuous applied force, and that's going to cause the acceleration, and this crate is going to go faster and faster and faster. Alright, see you on the next one.